Let's get back to the top questions from Microsoft on LeetCode. Today, let's do a trees and graphs problem, and let's work on validate binary search tree today. So, the premise of this problem is basically you're given a binary tree, and you have to determine if it's a valid binary search tree. And these are the three criteria for whether it's valid or not. The left subtree of a node should contain only nodes with keys less than the current node's key. So, for example, over here we have 2 as the top node, and we have 1 as the left node of this original node. And as you can see, 1 is less than 2, so that checks off. And our second condition is that the right subtree of a node contains only nodes with keys greater than the node's key. So 3 must be greater than 2, which it is. So this tree is valid. We also had that both the left and right subtrees must also be binary search trees. So let's take a look at example 2. We have 5, and the left subtree has a node 1. And 1 is less than 5, so that part is valid. But as you can see, 4 is on the right subtree of 5, but it's less than 5, and it's supposed to be greater than 5 if we want the binary search tree to be a valid tree. So the answer for this is going to be false. Now let's work on the code part of this. What we're going to have is a helper function actually. So we're going to call it validate tree. And we're going to have 3 parameters for this function. It's going to take in a root. It's going to take in, well, this is the original, it's not the original definition of the function, but this is basically what we'll be returning, and this is all for the original part of the function. Now we'll have a Boolean function here, which will be validate tree. We're going to have 3 tree nodes as the parameters. We're going to have max, so that we can compare it to the max, and min, compare it to the minimum. First of all, we want to say that if it's not a valid tree, we actually return true over here, because it is a valid tree if it has nothing in it, at least at that point. And our other conditions are if max exists and the current value we have in our tree, if it's greater than or equal to max, then we have to return false. So root of val is greater than or equal to max value. And our other condition is if there is a minimum and the current value is less than or equal to minimum, we return false. Because we can see by the time we get to a certain element, if it's greater than what its predecessor, then it's not a valid tree. I know this might sound a bit confusing, but we'll go through it with the example, and hopefully it should give you more clarity. So our final statement is that we just continue where we intended to go. So we go left and we go right. So root will be our new max, because when we go left, we're comparing it to the maximum it can be, which is in this case 2. And validate tree root of right, and we leave, yeah, so max and root, because when we go right, this has to be greater than this, the root, which will be the minimum parameter, and max is just what it is currently. So let's run this code, finish, and yep, we can see it works. Passes all 25 cases, 75 cases. Let's go through it with the example now. So let's take example one. So we have 2, and we have our original statement here. So our root's going to be at 2, and we're going to have 2 null pointers. So root exists, so this doesn't return yet. And now we have max, and if the root's value, if this is like this statement doesn't go through, it doesn't because we have a null pointer as max and minimum. So for the first node, it is basically, it just goes through the statement. Then we return the left of the current node and the right of the current node. So if we look at 1, we're returning, this is going to be 1, this is going to be 2, and minimum is going to be null pointer. So once we go into this, we have a max, and we have root's value, which is equal to 1, and we have max, which is equal to 2. So as you can see, 1 is not greater than 2, so we just continue. So this is not um, valid. And then we send it to left and right of the subtree 1, and it goes to a null pointer basically. So this means that we return true, and we can just go back up, in a recursive manner, and say that this part of the subtree is definitely a valid boundary search tree. Now we go to the right side, and we have 3. Uh, so a root of right is 3. Our max is whatever max is right now, so that's a null pointer, and our root, which is minimum, is going to be root, which is 2. And then we go to this statement because we have valid minimum, and root of value. So our root is obviously 3. If that's less than equal to the minimum, which is equal to 2, then we return false. But we can see that 3 is greater than 2, so we just continue. And then as we did before, we go to left and right, and we see that the left tree is a null pointer and the right tree is a null pointer as well. This basically means that we have a valid boundary search tree on the right side as well. So yeah, so we can see that we return true, it is a valid boundary search tree, and that is basically how you do this problem.